All right, welcome everybody. Today we're going to talk about lesson number 70. We're going to talk about section 9.3 and begin our discussion about geometric sequences and series. Now, when you compare those to arithmetic sequences and series, you might say that they're a little bit harder, but mostly they're just different. So all the rules and formulas that you learned about arithmetic sequences and series do not apply to geometric sequences and series. They have their own rules and their own formulas, which we're going to see today and in lesson 71. So to start us off, we're going to talk about the definition of a geometric sequence. So in order to be geometric, the ratios of consecutive terms have to be the same. A ratio, of course, means a division. So if you have the sequence A1, 2, 3, all the way up to A sub n, it would only be considered geometric if there was something called a common ratio R, and of course, R cannot be equal to 0, such that if you divided any of the later terms divided by the term in front of it, you would always have to get the same common ratio. So if you divided the second term by the first term, or you divided the third term by the second term, basically any of the later terms divided exactly by the term in front of it, you would always have to get the same value of R, which would be called the common ratio. The first thing you have to be able to do is you have to be able to find a common ratio R given a geometric sequence. Again, be careful of the question, because if they tell you it's geometric, you know for sure that it is, and you really only have to test one, maybe two ratios. If I'm asking you if it's geometric, you have to test all of them, because if somebody doesn't fit, then the answer is no, it's not geometric. So consider number 1, 2, 4, 8, 16. This is in fact a geometric sequence. The ratio, the common ratio R is 2. And to find it, I would take any term, let's say 16, divided by the term in front of it, which in this case is 8, and I would get a common ratio of 2. Notice that whatever pair of terms I picked, whether it was 8 and 16, 4 and 8, 2 and 4, as long as you find the ratio of consecutive terms back divided by front, you should always get the same answer, which will be your common ratio. For number 2, that is in fact geometric, and the common ratio is -1/3. Be a little bit more cautious when you're trying to find the common ratio with some fraction action. So again, because we know that it is geometric, I could pick any two terms. Let's say I pick these two. In order to find that common ratio, I would have to divide the later term, -1/27, by the previous term, which is 1/9. Of course, dividing by fractions is really the keep, change, flip. So -1/27 times 9/1. Go ahead and reduce. And that's how you would get a common ratio of -1/3. And then in number 3, notice that I start by giving you an equation. So you're going to go ahead and plug in n equals 1, 2, 3, 4, however many you like. That's now going to give you a sequence. And if you were to take any pair of consecutive terms, let's say 36 divided by 12, you should in fact get a common ratio each and every time, which in this case is 3. So in the same way that an arithmetic sequence is always linear, a geometric sequence is always going to be exponential. The form that we are most commonly going to use is A sub n equals the first term times the common ratio raised to the n-1 power. So a couple of examples down here of that formula in action. Basically, the first term would be equal to the first term because there's no common ratios between them. If you wanted to talk about the relationship between the second term and the first term, you would have to multiply the first term by exactly one common ratio because there's one common ratio between the first and second term. If you were talking about the third term and you were starting with the first term, you'd have to multiply by exactly two common ratios, R times R, better known as R squared, because there are two ratios between 1 and 3. This is similar to the way in the arithmetic section, how we took that equation and was able to write a relationship between any two terms. That's the same thing here. Let's say you wanted to find a relationship between the 10th term and the third term. Well, to get from the third term to the 10th term, you'd have to multiply by exactly 7 R's, better known as R to the 7th. Okay, for example 4, find the first 5 terms of the GS, that of course is geometric sequence, with the first term of 3 and a common ratio of 2. So if we're going to use the formula as I've given you, that's the first term times R to the n-1. That's going to give us a formula of 3 times 2 to the n-1. Because you're trying to find the first 5 terms, you're going to go ahead and plug in the terms 1 through 5, and that is going to give you 3, 6, 12, 24, and 48. Of course, you can see here that with a common ratio of 2, it essentially means you're doubling from one term to the next. So if you kind of see that pattern, then yes, obviously you are able to use it. I also want to kind of give you a little note here. So again, in our book, this is the formula that they tend to use. Sorry about that. They tend to use to the n-1. That's the one that I'm going to use most of the time. But I want you to know that there is a way to find equivalent formulas, ones that don't use n-1, but instead just use n. So if you wanted to do that, again, not that you have to, but I'm just saying that if you wanted to, you could break up the 2 to the n-1 and break it up into 2 to the n times 2 to the -1. And again, the reason why that would be legal was because if you were to try to then go backwards, if you have base 2 and base 2, you would add those exponents. So you're allowed to work in reverse and split them up. If you take a look here, this would be 3 times 2 to the -1, which would essentially be 3/2. And then this would leave you with just 2 to the n. I want you to realize that this equation would yield you the same exact 5 terms. So these two things are in fact equivalent. I tell you this mostly for the problems later on where you're asked to find an equation. Again, I would advise you to use the n-1 form just because that's what we're going to be using the majority of the time. But please note that if you were to find something that's equivalent, that would obviously be acceptable. Find the 12th term if you're given 5, 12, 45. So from here, you're going to go ahead and realize again that this is the formula, A1 times R to the n-1. We have the first term. What we need is the common ratio. If I'm telling you that it is in fact geometric, you can take any term, let's say 45, divided by the previous term, and that's going to give you the common ratio, which in this case is 3. That would mean that our formula is 5 times 3 to the n-1. And again, perfectly fine to leave that as your answer. You might, find the equivalent answer if I told you to, just with n, but this is perfectly fine. And then if you're trying to find the 12th term, that's going to be 5 times 3 to the 11th, which again should make sense because to get from the first term to the 12th term, you'd have to multiply by exactly 11 common ratios, better known as r to the 11th. Hopefully you can tell here that 5 times 3 to the 11th is going to be quite a large number. In fact, it's 885,735. When it comes to geometric sequences, they're going to get really big and really small really fast, and that's okay. So you kind of just have to know that going in. Number 6 is a similar question, so feel free to pause, try it on your own, and then verify that you do in fact get the correct answer. So again, keeping our formula in mind, you know what the first term is, but you have to find the common ratio. If you know it's geometric, obviously choose the easiest pair, which certainly involves not the fraction. So -2 divided by 6 is going to give you a common ratio of -1/3. Make sure that you don't lose that negative. If you were trying to find the 10th term, it would be equal to the first term, which is 6, times exactly how many r's there are between 1 and 10, which would be to the 9th. So 6 times -1/3 to the 9th. And if you wanted to plug this in your calculator, that's fine, but you have to be a little bit careful. The answer that your calculator will most likely give you is -3.04 e -4. As a reminder, this is scientific notation. You have to be able to take that and turn it into an answer that's a little bit nicer. So because the decimal point is currently right here, this e to the -4 means that you are going to move that decimal place 4 spaces to the left. So if you take this decimal point and you move it 4 spaces to the left, you are going to get a value of -0.0003. It might actually be easier to just tell your calculator to leave it as a fraction, in which case you get -2 over 6561. That's a very small number. Again, the previous example got very large. This one gets very small. So I would take either of those two answers, but I will not take this thing with the -4. So if you're going to use the decimal, you have to make sure that you're able to convert it to -0.0003. Otherwise, just tell your calculator to leave it as a fraction. What if I tell you that you have a geometric sequence where I give you the 4th term and I give you the 10th term and I ask you for the 14th term? So this is actually going to look very similar to what we did back with the arithmetic. So you have the 4th term and you have the 10th term. So you're going to set up a relationship between those two things. The 10th term of a geometric sequence is equal to the 4th term times r to the 6th. You would have to multiply by exactly 6 common ratios to get from the 4th term to the 10th term. So 125 64ths would be equal to 125 r to the 6th. You're then going to multiply both sides by 1 over 125. I mean, essentially you're dividing by 125, but this makes it a little bit easier. If you multiply by 1 over 125, it's going to cancel over here on the left-hand side, and that's going to give you 1/64 equals r to the 6th. Now you have r to the 6th, but what you need is r. So in order to get rid of a 6th power, you're going to either take the 6th root of each side, or you're going to raise each side to the 1/6. And if you're going to be raising something to the 1/6, you're going to want to make sure that you use parentheses. So again, you're basically doing 1/64 raised to the 1/6. In your calculator, you can also do the 6th root. The reason why this is actually kind of nice is because the 6th root of 1 is 1. The 6th root of 64 means what number to the 6th power is 64. And again, luckily for us, it turns out to be 2, which means that the common ratio is 1/2. Notice that they didn't actually ask you for an equation in this problem. All they asked you for was the 14th term. So you don't actually have to find the whole equation. All you have to do now is set up some kind of a relationship where you can find the 14th term. So the 14th term is equal to, choose either of the values that you have. I think I'm going to use the one without the fraction, is equal to the 4th term times r to the 10th. Then you're going to be able to see that the 14th term would be equal to 125 times 1/2 to the 10th. And again, from here, feel free to let your calculator do the heavy lifting. So your answer, let me write it up here. Sorry, I ran out of room. If you plug that into your calculator, you're going to get 125 over 1024. Should you want to make it a decimal, that's acceptable as well, which would give you a final answer of 0.122. So again, getting very big and very small, we kind of know that going in. Feel free for number 8 to pause and try it, see if you're able to set up a similar process to the previous problem and get the correct answer. So again, we are looking for a sub 7. So I'm first going to take what I have, which is a sub 5, and realize that to get from the 2nd term to the 5th term, I would multiply by exactly 3 r's. That would mean that 2/3 is equal to -18 r to the 3rd. Divide both sides by -18 or multiply by 1 over -18 to both sides. And that is going to give you -2 54ths, which you could then, of course, reduce to give you -1 27. And that would be equal to r cubed. We don't actually want r cubed, we want r. So to get r, you would have to raise both sides to the 1/3 power, or again, take the cube root. The cube root of -1 is -1. The cube root of 27 is 3, which is what makes the common ratio in this problem -1/3. In order to find the 7th term, you again have to set up a relationship with either of the two things that are given. Again, it does not actually ask you for the entire formula, so you're allowed to skip that step. Up to you. Let's say the 7th term, I'm going to use the non-fraction, would be equal to the 2nd term times r to the 5th, which would be -18 times -1/3 to the 5th. Be sure to use those parentheses. Use the calculator, and that is going to tell you that the 7th term is going to be equal to 2/27. And again, if you should prefer a decimal, 0.074 would be perfectly acceptable. So the truth is, geometric sequences and series, I didn't want to do it all at once, so this is a little bit of a shorter lesson, which I think means it's a really good time for you to do a pause and try some review problems. It's very likely that we'll be talking about an assessment next week. So my advice would be to pause right now and to try these 3 problems to start. You're basically going to find the first 4 terms in each sequence. Then you're going to classify it as arithmetic, geometric, or neither. So again, pause, try it, and then when you have the answers, move on to the next screen. Now that you've tried the 3 problems, here are the answers. You can see that in example A, it is geometric with a common ratio of 8. In number B, there is no common difference, meaning it's not arithmetic. There is no common ratio, meaning it's not geometric. And as far as we're concerned, if it's not geometric and it's not arithmetic, that's a neither. Finally, for the last one, notice that it is in fact arithmetic with a common difference of 2. One more pause and try here. So one of the biggest things you have to be able to do is if I was to give you any sequence, and here there are 6 different ones, you have to be able to find the explicit definition, also called the nth term definition. It basically just means the formula for A sub n. Use the term numbers. Remember, you might want to write underneath first term, second term, third term, fourth term. And my advice would probably be this. Now that you know that arithmetic sequences all have the same looking formula, dn plus c, and now that you know that all geometric sequences have the same formula, a1 times r to the n minus 1, I would probably look at these 6 problems, try to identify the ones that are arithmetic or geometric, and try to do those ones first, because all you have to do is use the formula. Or if it doesn't require a formula, then I would suggest writing the term number 1, 2, 3, 4, and then again, a little bit of educated guessing and checking, trying to see if you can find those equations. So again, I strongly recommend you pause, try these 6, and then move on to the next slide when you're ready. Here are the answers to those 6 problems. So in A, this is arithmetic, which is why it looks like y equals mx plus b. Here in C, this is geometric. And F is also geometric because there is a common ratio. For the other 3, if you take a look at B, if you were to write first term, second term, third term, fourth term, you would hopefully realize that the numerator is the term number plus 1, where the bottom are the perfect cubes. For D, once you see that alternation in sign from positive to negative, you know it has something to do with a -1. And remember, it's either going to be -1 to the n if the first term is negative, or to the n plus 1 if it's positive. And then finally in E, the top are the powers of 2, and the bottom are our good friends, the factorials. Last thing I want to point out here is, again, for C and F, each of those has an equivalent equation using n as opposed to n minus 1. So let's say for number C, if you instead wanted to find an equivalent formula, you could do 64 times -1/2 to the n times -1/2 to the -1. If you were then to consider -1/2 to the -1. The -1 means you're flipping the fraction. So instead of being -1/2, it would actually be a -2. -2 times 64 would give you -128. And then you'd be left with -1/2 to the n. So again, all I really want to point out in these examples is that these 2 equations are equivalent. You will get the same terms, which really that's all we care about. So if you were to use either of them, that would be fine. And of course, if I was to specifically ask for one versus the other, please make sure you could do that as well.